Hello, how y'all doing today? My name is Bernie Thompson, and today we're here to take a look at this 2008 Subaru Legacy. This little Subaru has a problem where it's setting cam sensor codes for bank 1, and apparently it had misfire codes set for 1 and 3. So what I first want to do is I want to get a scan tool, and I want to get some very basic data out of this car. So let's go ahead and get that scan tool connected. Okay guys, the shop I'm doing this work for, when he first started to do the work, he made a printout of the codes, and this is that printout. So he's got a P0340, which is bank 1 camshaft sensor circuit malfunction, and then he's got a secondary air injection problem, and then he's got a misfire on 1 and a misfire on 3. Now, the DTC for the cam sensor, he replaced the cam sensor, and he's fixed the air injection problem. It had some hose problem. And the misfire on 1 and 3, this car had the wrong spark plugs in it. The spark plug they had in there was a real short plug. It didn't even go down into the chamber. He's put the right plugs in it, and he's fixed the misfires, and he's fixed the air injection, but he still has a cam sensor code. So let's take a look at those codes now. What I want to do is I want to come over here, and we're going to open up the DTCs, and we have a P0011, which is the cam position sensor for bank 1, but this has a timing fault now for over advanced. So with the new sensor in there, it's setting a different code now. Now the misfire and the air injection, they're no longer setting a code, but we have something going on with this cam sensor on bank 1. So the first thing I want to do is I want to get a scope on this, and I want to look at the cam and crank sensors together, and I want to see what's going on. Why is this guy setting a timing error now? So let's go ahead and get that scope on this vehicle. Okay guys, let me show you how I've got the scope connected. I've got channel 1 yellow connected to the cam sensor for bank 1. I've got channel 2 red connected to the cam sensor for bank 2. I've got channel 3 green connected to the crank sensor, and I've got channel 4 connected to an eSCOPE, and I've got it on the number 1 coil. Okay, I want to go ahead and set the scope up. So I want to come to channel 4, and I want to go to a 20 amp. That'll give me a 10 times multiplier. Then I want to 0 that one. And then we want to come over here, and now's what I want to do is I want to load a known good waveform. So this is this 2.5 turbo motor, known good. The cam is on yellow, bank 1, cam bank 2 is on red, and the crank is on 3. So let's go ahead and take a look at this. So now this is our waveform. So the first thing is the bank 1 is being pulled down and bank 2 is being pulled up. Notice they're inverted from each other. Now, this is the way they should be. The next thing I want to do is I want to take a cursor down these edges . And we can see that these edges line up pretty close. And they're basically, these edges are aligning with the last pulse before the index. You can see it's almost coming through the peak. This is the index point. And this is the single index point, and these two are lining up with the last pulse before the single point. So that's known good. Now let's get a waveform off of this car. We already have a problem, guys. So we already have a problem the two cam sensors are inverted. The bank 1 should be being pulled down, and bank 2 should be being pulled up. Those are not right. Those are inverted waveforms. So there's something wrong right here. Now it's only setting a code for bank 1, but both sensors have an issue. Remember, in the known good one, watch. This is what we have on this car. I'm going to load with known good. Turn off the... See, bank 1 is being pulled down and bank 2 is being pulled up. And that's not what we have here. Yellow's bank 1, and it's being pulled up, and bank 2 is being pulled down. Bank 1 is being pulled up, and bank 2 is being pulled down. These are inverted from each other. That shouldn't be the way they are. So this has something to do with the sensor, because the computer is feeding the 5-volt signal out, and the sensor is pulling it to ground and releasing it. And these are just swapped. So that's crazy, okay? That's pretty crazy. So again, we can clearly see that bank 2 is being pulled down and bank 1 is being pulled up. These are exactly opposite of what they should be doing. So one thing I want to do, okay, I want to give this a little rev and see what this is going to do. Okay, so bank 1 flipped and now it's correct, it's being pulled down, and bank 2 is still being pulled down. This one's wrong and this one's right now. Wow, holy moly, that's insane. Look at that, guys. Bank 2 is being pulled up the way it should be, and bank 1 is being pulled. They're right there. That's right. And look at right here. It flipped. And when it flipped right there, now it's wrong. But right here, it's right. So these are the way it should be right here. Now, let's turn this guy back on. Okay, right here, it flipped. That's right. Bank 1 is being pulled down, bank 2 is being pulled up. Now that we're correct, is what I want to do is I want to see if it's in time. Okay, so that's my double piece. That peak right there should line up with them. It's off just a little bit, but it doesn't look like it's far enough to set a code to me. The difference is between that peak and where we are. This is what I need to do here. We're going to go from the first peak to the first peak. I'm going to mark it. Now is what I want to do. So I want to measure the difference between the edges. So that last peak right there to the edge is what we're interested in. And we're 11 degrees. You know, 11 degrees might set a code because that's more than 10 degrees for your cam. But I don't think that that's what's wrong, because we can clearly see what's going on, and it's flat. See how they're both going the same way now? These should go in opposite directions. Well, if we're measuring the edge, do you see how if I looked at that edge, it's way off from this edge? And that's a lot more. So if I get my cursors here, the edge to edge, look at how many degrees we're off there. It's a huge amount. So that's not, the reason that the car is setting codes is because, guys, the reason the car is setting codes is because they're flipping, and both of them, both sensors are flipping, guys. Did you see that? Bank 1 and bank 2 are inverting from each other. Now, that's insane. I've never ever seen a problem like this. I mean, right now I don't even have an idea of exactly what to check. I don't know what would cause that. I mean, to flip the magnetic intensity like that, the only thing I can think of is the shafts might be magnetized, but there's no way I can magnetize both cams. So maybe I'm thinking I need to check the alternator and see if it's got a diode leaking. Maybe a bunch of AC could do this, but the only thing I can think of right away that would cause us a problem like this is the wheel is magnetized to flip them both. And both of them flip, and it happens when we change the speed. So if we go back out, okay, bank 1 is being pulled down and bank 2 is being pulled up. That's right. Right here, bank 2 started to be pulled down, and it needs to be being pulled up like here, and it's flipped. That's crazy. Let's do this again. I just want to see this one more time. Let's rev this thing again and see what happens. Right here, bank 1 is being pulled up, and it should be being pulled down, and bank 2 is being pulled down, and this is wrong. So both of those are wrong right there. And right here, it flipped. Do you see how it was being pulled up, and now it's being pulled down? And that's right when we started to rev it. We can see it because the crank sensor gets bigger. Because the crank sensor is a variable reluctance. The faster it goes, the bigger the signal got. We can see right when we started to rev it, it flipped. And then look over here at bank 2, it flipped. In fact, they flipped within 327 milliseconds of each other. So they both flipped, and they're both flipping. Now guys, that's insane. I've never seen anything like that. You know, I keep coming out here and working on cars, and then I just get these crazy, crazy cars. Because guys, that's one crazy problem. How can both sensors flip and they're flipping within just a few hundred milliseconds of each other. What would cause that? Maybe the AC ripple off the alternator. So I want to go ahead and I want to change, put a lead on there, and I want to look at that. So let's check the alternator real quick and just see what that's doing. Okay guys, when you check alternator ripple, you've got to be on the alternator. Never check this at the battery, because the battery acts as a big capacitor. So I want to be at the alternator, and that's what I need. Okay guys, this is the alternator. So take your zoom window. Do you see all these humps? 1, 2, 3, that's the 3 diodes. 1, 2, 3, that's the diodes. What I'm looking for is one of these to be falling more and more. Like one of them has a bigger output. Now this is at idle, and this is not where I had my problem. And what these are is where things are turning on, like coils and injectors are turning on. These are voltage drops. I don't care about the voltage drop. These drops right here, if one of them drops way more than the others, that's one leaking. And if like right here, that sort of looks like it could be leaking, there would have to be 3 away again. 1, 2, 3, and that one's not dropping more. If it's leaking, it will be every third one. So now is what I want to do is I want to rev it like I did before when I got the car to fail. Okay, so now I want to take the zoom window and we want to come in over here where we revved it, right in here. And again, where these drops are is where things are turning on and off. Don't worry about that. See how I have good 1, 2, 3, 1, 2, 3, 1, 2, 3, and none of these are dropped way lower? These need to start dropping down further than maybe half a volt before I'm going to worry about it, or a volt. They got one of them will start dropping, but it will be very repetitive. And I don't see that dropping. So no, the alternator is fine. I don't have alternating current that's tripping this up. It's something else. And the only thing I can think of right now would be magnetized trigger wheels. The faster that trigger wheel goes, the less magnetic energy remains on that circuit, and then it flips it right. And when it's going slower, it's got too much magnetic field on it and it flips the sensor. Let's see what we had happen down there with the sensors. We didn't look at that, but I'm interested. Did it do it again? And right away we can see that we inverted right here. This is wrong. It's being pulled up. It should be being pulled down. It went correct right here. And this one should be being pulled up. It's being pulled down. Do you see how both of those are inverted? And right here it went right. So let's turn that guy off. Do you see where it flipped right there? So let's see what it did this time. So that's where it started to work right. And that's where that one started to work right. 116 milliseconds. These are happening really close to each other. And once again, it happens right when we start to accelerate and that shaft starts to turn faster, is where they get fixed. And when it's turning slower, they're both inverted. So let's check it now. So right away it's going slower and they've inverted again. This one should be getting pulled down and this one should be being pulled up, and they're not. So I can't, what I'm blown away with, How is this not setting a code for both banks? It's only setting a code for one. That's crazy, guys. This is one crazy car. Wow. That is a crazy car. So right now, these are wrong. So what I want to do this one more time. I always like to see these things happen multiple times before I start chasing my tail. Let's speed it up and see what happens. So we're pulling down and we're pulling up, so this is right. And this is wrong. We rev the car and it gets right. We idle the car and they're inverted, and it's both sensors. And I'm just not sure what would cause that. And let's see this time how far away those are from each other. As soon as we start to spin the engine faster, they both flip 135 milliseconds. So whatever is affecting both of them, it's really close to the same time that they're occurring at. They're both flipping as soon as we start to spin the engine faster. That's the data that we can clearly see what's happening. They both flip when we spin the engine faster. I'm just not sure what would cause that other than a magnetized target wheel. Okay guys, in order to see what's going on with the Subaru, the easiest way for me to check to see if the shaft is magnetized, the trigger area or the trigger wheel on the camshaft, is we just remove the valve cover. Once I remove the valve cover, and we also remove the sensor, so I don't want any magnetic energy down there that might trick us. So the sensor's been removed and we remove this valve cover. And there's a ground that's on the head that was not on the head. It doesn't go to the valve cover, it goes to the head itself. And there's a ground cable that's supposed to be connected to that head that has been off for some time. And you know, when you get these grounds and they're not on the engine right, that's what gets these shafts magnetized. So now let's go ahead and check this shaft with the instruments I have here to check for Gauss or magnetic energy. Okay guys, when we pulled the valve cover, this ground is supposed to go over to this head, and you can see that it hasn't been connected. Do you see how rusted it is? That ground has not been on this head for quite some time, and without having this ground cable on there, it changes the current path and it's magnetized that cam now. You can see the little cutouts in the cam. That cutout is what's making the cam sync. So it has cutouts around that cam, and that's what syncs that cam. Okay guys, so I have two tools that we're going to use to check for magnetic intensity. First, I've got a drill bit that's magnetized, so let's just make sure that this is still a magnet. Okay, clearly that drill bit is magnetized. We can see that it's holding a magnetic field and it's holding that band clamp. So now what I want to do is check this. This is a sensor probe right here. And we want to cross that 5, 12, 4, 2, 6, 4, 5, 6, 7. I'm just moving it back and forth right in front of that bit, and we know the bit is magnetized. It's definitely magnetized. So we can see this reading right up here is going to change when it's in front of that magnetic field. So if this is reading any kind of magnetic field, we're going to see we're going to get a reading 3, 2, 10, 4. So the bit is definitely magnetized and it's showing it. The second one I want to show you, you can download on your phone. So if this is magnetized, now you can see the little pointer goes up into the yellow. The higher it gets up into the yellow, the more magnetic field this is. But we can see that it's getting into the yellow there. So it definitely is showing a magnetic field. And it all depends on the angle you are to the field, to how good you're going to read it. So reading these on some of the engines is going to be more difficult, because to get it down next to this camshaft might be difficult. But we'll get some reading. If it's magnetized, we'll see it. We can see that little marker going into the yellow. And when that little marker goes into the yellow, now I want to show you the difference between a real magnet and a piece of metal that's magnetized. Now this is a real magnet. We can see we're in the red clearly with this. And we'll also check this and we'll see that a magnet's going to make this operate quite differently. 41, 105, 126, 189. It's got 130. It's way bigger numbers because this has a stronger magnetic field. But something like on a crankshaft or a camshaft that's become magnetized, it's going to become, it's more like this drill bit. It isn't going to be in the hundreds. 14, 5, 4, 5, 3, 4. It's just going to show a light magnetic intensity, and that's it. It's not going to be in the hundreds. If it's in the hundreds, it's a magnet. And the shaft, they're not going to be fully magnetized. So again, we're going to be able to see that we've got a magnet. We can see that it definitely reads it. It's getting into the yellow, and this is definitely magnetized. And the other thing is the angle that these are at changes the field and how it reads it. And we can see that the angle is going to change that. So depending on how you can get your sensors to read the intensity from the magnet is going to change how it's going to read it. But we can see that this is magnetized. We definitely know it's a magnet, and we definitely can see that both of these instruments that I'm going to use show that this is magnetized. So if these cams are magnetized, one of these or both of these should show that cam is magnetized. Let's go ahead and get testing, and let's test this shaft to see what's going on. Okay guys, 7.5, 5.8, 4.3, 3.6, 5.6, 7.8. I'm just moving the probe on this trigger wheel back here. 6.5. Do you see it picking up that magnetic field, the intensity? 3.8, 3.6, 5.1. Okay, so that's me moving this on the cam. Now I want to try my phone. We're going to use the phone app to check this with. So if I come back here, you can see that we're coming up into the yellow. I'm just moving it back and forth across that cam. Do you see how the mark is coming? See how the mark is coming into the yellow? It's really, really lightly magnetized. This shaft isn't very magnetized, but it doesn't take very much. We're definitely into the yellow, and that's magnetized. So we have two different meters here that are both showing that this camshaft is very lightly magnetized. Okay guys, is that just too cool or what? Is this just an unbelievable little Subaru? Both cams are magnetized on this car. Never seen anything like it. This is a great car. This is a great, great car. Okay, so now We're going to have to figure out how the customer wants to proceed with this, because really the cams need to be replaced. But I guess the cams, the shop is telling me they're like $700 a cam. So I don't know the customer is going to want to spend $1,400 plus the labor. They might just want to get a used motor and put it in, but I think these turbo motors are pretty expensive used too. So I don't know, it's not my job. My job was just to diagnose the car. Now we know the cams are magnetized. Now it's up to the customer in the shop to figure out how the car is going to actually become fixed. The other suggestion that I've made to the shop is we could pull these cams and take them out to the airport and put them in a Magnaflux machine and demagnetize the cams in a Magnaflux machine. We also, in another video, I went over a degaussing machine I made. We could degauss them. There's a lot of possibilities, but normally what I've done with these type of cars is we've just replaced the cams with the shafts that become magnetized. It's really easy, and I know that's a good fix as long as you fix the grounds. Now both heads have grounds off of them. You gotta look at the grounds, and you gotta fix the grounds, and you gotta make sure that the cable going to the starter has a good ground. It'll be imperative to make sure that the car doesn't reflip it once you put new cams or shafts in this car. Okay guys, I want you to understand something. In every video I show you an approach. It is always a data-driven approach. You don't got to worry about what kind of car you're working on, and you don't got to worry about every TSB. What you got to know is you got to have some basic principles of electronics. You guys are going to have to get trained in electronics. There's all kinds of classes on YouTube. Get on YouTube, find some electronic classes. Not automotive electronic classes, electronic classes that teach you how to build circuits and how they work. Once you know how electronics work and circuits work, then you just need a basic scan tool and a good oscilloscope, and you can fix any car. Just stick to the data. This is data-driven analytics. Let the data drive the test and then go from that to the next test. There's no silver bullets, guys. There's no TSBs. Oh, I know this car so it's got this problem. I keep seeing all this online. Oh, I know that car, it does this. Well, yeah, what happens when that isn't what's doing it? I mean, who would think that both shafts could be magnetized? It's time to learn how to diagnose cars, and that's learning how electronics are in operation. And once you understand electronics, the scope is showing you what's happening with the electronics, and then it's easy, guys. Data-driven diagnostics, that's how you fix cars. You guys need a good scope, and you need to know how electronics work, and you too will have good troubleshooting in your base.